So let us see some other examples. Again, these are the special case. So example number 1. Vector So vector A is given in spherical polar coordinate, that is r cap by r square, and you have a spherical volume. This radius is r. You have to verify divergence theorem. Let us verify divergence theorem. Divergence A d tau is closed A dot dA. For this volume, verify the divergence theorem. So first you have to calculate left hand side divergence of A, and then this volume is surrounded by closed surface. So whenever you have to verify divergence or Stokes theorem, you have to calculate divergence of a vector or curl of a vector. So let us first see what will be divergence of A in a spherical symmetry. This is 1 by r square del r square into AR. AR is 1 by r square. So this r square will cancel out. This will be 0. Divergence A is 0. But you can see divergence, you will see that this divergence A is 0 except at one point, that is r is equal to 0. So at r is equal to 0, what will happen? This term tends to infinity. So it's a special case. Whenever divergence or curl is 0, that may be a special case, because mathematically divergence of A is 0. So if you write divergence of A d tau, let's say in objective question, if you have calculated only this value, divergence of A, you will write divergence A is 0. But in these case, always check for right hand side. Don't write directly 0. Check for the right hand side also. So what will be right hand side? A dot d over this surface. So this is r is equal to capital R, and this direction is r cap. So r is equal to capital R dA will be r square sin theta d theta d phi r cap. So this will be r cap by capital R square dot capital R square sin theta d phi r cap. So r dot r is 1, r square will cancel out. So this will be sin theta d phi. So this will give you closed A dot dA is sin theta d phi. Theta will be 0 to pi and phi will be 0 to 2 pi. So sin theta d theta 0 to pi will give you 2 and d phi will give you 2 pi. So you can see this is 4 pi. right hand side is 4 pi. So this integral is not 0 because divergence theorem is always valid. This integral will be 4 pi. So in objective question, whenever left hand side is 0, you have to be attentive that it may be a special case. Always check for right hand side. So this right hand side is 4 pi. So divergence of A d tau will be also 4 pi. Now how you will get divergence of A d tau 4 pi? Because mathematically you have calculated divergence of A is 0. So as I have told you that divergence of A is 0 at all point except at one point, that is R is equal to 0. So we can represent divergence of this vector in a special form, and that is in terms of Dirac delta function. And you know properties of Dirac delta function. So how to express divergence of A for vector r cap by r square? It's a special function that you have to express as 4 pi Dirac delta function. This is, I have written Dirac delta function in 3 dimensions.
So why is this required?
Because divergence is 0 at all point except at one point, and we have Dirac delta function that can be represented in this form, that Dirac delta function is 0 at all point except at one particular point. So that's why divergence can be written in this form. If you see Dirac delta function, how to define Dirac delta function? This is 0, or you can see this is infinity at r is equal to 0, and this is 0 when r is not equal to 0. So you can easily explain divergence of this vector function. You can see this will be 0 at all point except at one point, and that is the divergence. So this divergence is 0 at all point except at one point. That's why I have expressed this in terms of Dirac delta function. And you know properties of Dirac delta function. That is how Dirac delta function is defined. That at r is equal to 0, this is infinity. At all points, Dirac delta function is 0. Is it clear? How to express divergence of r cap by r square? It's a special vector. You have to remember this case. Whenever you have r cap by r square, you have to express in this form. You can see in this formula also you have r square 1 by r square term. Then this will cancel out. Even if it is 1 by r cube, 1 by r, then you will get divergence is non-zero. But whenever it is r cap by r square, you will get it will be 0 value. So you have to express in terms of Dirac delta function. Is it clear? So you have to see some properties of Dirac delta function. For example, this is the definition, how to define Dirac delta function. You have another property also, that if you take volume integral d tau, take it as all space. What does it mean? All space means this integral must include r is equal to 0, because delta r is defined at r is equal to 0. So if it includes r is equal to 0, this integral will be 1. Otherwise it will be 0. If this integral doesn't include r is equal to 0, then integral will be 0. But when it includes r is equal to 0, this integral will be 1. So you have to remember this property of Dirac delta function. Then we can easily write volume integral. So now what will be volume integral? How to write volume integral? Divergence r cap by r square d tau. This is 4 pi delta r d tau, and this integral is 1. So you can easily write this as 4 pi, because this includes r is equal to 0. This includes r is equal to 0. So integral will be 1. So you can right, divergence of r cap by r square d tau is 4 pi. So now you can verify that both right hand side as well as left hand side is 4 pi if you express in terms of Dirac delta function. Otherwise, you will get this is 0 and this is non-zero. Is it clear? This is the special case where divergence is 0. You can see some other properties of Dirac delta function. In this case, this is defined at r is equal to 0. We can also define Dirac delta function at other point. For example, r minus a. So this will be infinity at r is equal to a, and this will be 0 when r is not equal to a. Or you can define delta r plus a also. So this will be infinity when r is equal to minus a. 0 when r is not equal to minus a. Again, volume integral r minus a d tau all space. In this case, all space means integral includes r is equal to a. R plus a d tau. In this case, this integral includes point r is equal to minus a. So you can see properties of Dirac delta function. We have other properties of Dirac delta function also. So that we can write let fr be some scalar function. Then integral fr delta r d tau. Volume integral all space means this includes in r is equal to 0. So this integral will be simply value of the function at r is equal to 0. Value of the function at r is equal to 0. Or you can have volume integral fr delta r minus a d tau all space. This will be simply value of the function at f is equal to a. Or delta r plus a d tau in this case value of the function at f r is equal to minus a. So you have to remember these properties of Dirac delta function. So using these properties, let us evaluate this integral. Integral, what will be r square to divergence r cap by r square d tau. Let us evaluate this. So evaluate this integral. So this will be r square plus 2. This can be written as 4 pi delta r in terms of Dirac delta function. Now this is some scalar function fr. So you have to put r is equal to 0. So that will be, value of the integral will be 0 square plus 2 into 4 pi. So this integral will be 8 pi. So using these properties, you can easily find fr delta r d tau is f0, value of the function f at r is equal to 0. This is the integral. Let us take another
Can you
case.
explain it again? Why we take r is equal to 0?
This is the properties of Dirac delta function. You can see fr delta r d tau, all space means this integral includes r is equal to 0. So that is value of the function f at simply r is equal to 0. So that will be f0 only. So this is fr, put r is equal to 0, you will get 8 pi. Let us take another integral, exponential minus r, divergence r cap by r square d tau. Calculate this integral. So this will be exponential minus r 4 pi delta r d tau. Put r is equal to 0. So exponential minus 0 into 4 pi. This integral is simply 4 pi. So just remember these properties of Dirac delta function. In this case, you have to remember this vector r cap by r square. Whenever you have to find divergence, express it in Dirac delta form. ठीक है? So in this case, divergence of A is 0. But right hand side is non-zero. So answer is non-zero value. We can also verify Stokes theorem. And let us take one example where curl is 0. Then you have to check for right hand side. So let us take again a special case.
Excuse me, sir.
Yes.
सर ये r कैप बाई 1 by r square जो ये फंक्शन है ये एक ही है या इस तरह के और भी फंक्शन हो सकते हैं जिनमें
This
डेल्टा
is
लेना है?
only one case, r cap by r square, because in formula you have r square into ar. So when ar is 1 by r square, that term will be 0. So that is the special case. You have to remember that vector function r cap by r square. So next example, a hemispherical shell is placed on the xy plane, centered at the origin. Centered at the origin. For a vector field A is equal to minus y x cap plus x y cap by x square plus y square. For vector field A, find the value of the integral del cross A dot dA over the hemispherical surface, over the hemispherical surface. So hemispherical surface is an open surface. It's a shell. Shell is an open surface. It's not a hemisphere. It's a hemispherical shell. Hemisphere is a half part of solid sphere. But it's a, if you have a shell, that is the hollow. It's a hollow sphere. So if you take half part, you will get hemispherical shell. So let us draw the hemispherical shell. X, Y, and Z. So you have to find del cross A dot dA over the hemispherical surface on this surface. This is r cap. Let us assume its radius is r. Radius is not given, but you can assume its radius is capital R. So let us see what will be curl of A. First, calculate curl of A. Find curl of A. What will be curl of A? This is x cap, y cap, and z cap. So del x, del y into del z. So this will be minus y by x square plus y square. This is x by x square plus y square, and this will be 0. So x cap will be this is 0 minus 0. And what will be y cap? Again 0 minus 0. And what will be z cap term? You can see if you differentiate this, differentiate with respect to x, this term will be del x into x by x square plus y square, and plus del y by x square plus y square. So this z cap term will give you, this is x square plus y square into 1 minus into 2x by x square plus y square whole square, plus x square plus y square into 1 minus 2y into y by x square plus y square whole square. So what will be this value? This is minus x square plus y square. So you will get minus x square plus y square, and this will give you x square minus y square. This will be 0. So del cross A is 0 here. So what will be this integral? If you see, according to this curl of A, this will be 0. But again, it may be a special case. So whenever divergence or curl is 0, and you have to verify divergence theorem or Stokes theorem, always check for right hand side. So in this case, right hand side will be closed A dot dl. You know that closed A dot dl is surface integral del cross A dot d. Surface integral del cross A dot dl. So now you have to find closed A dot dl. So how you will calculate closed A dot dl? So this hemispherical surface is surrounded by closed surface. And what is the closed surface? This is surrounded by this closed line. This hemispherical shell is surrounded by closed line, and closed line is the circle. Is it clear? This is an open surface because it's a hollow hemisphere. So that is surrounded by closed line, and you have circle that surrounds the hemispherical shell. So you have to find line integral over this circle. So how you will calculate?
Cylindrical symmetry.
Which symmetry?
Cylindrical symmetry.
Cylindrical symmetry. So now you can see difficulty of this problem. It's not a simple question. Just see, vector is given in Cartesian coordinate, and you have to find del cross A dot dA over the hemispherical surface. But if you calculate curl of A, it is 0. So it's a special case. Now you have to find right hand side closed A dot dl. So that A dot dl is over the circle because circle surrounds the cell. So if you see symmetry, this symmetry you will see it as a spherical symmetry. But since you have to find line integral over the circle, so you have to use cylindrical symmetry. Is it clear or not?
Yes, sir.
So this is the best example till now what we have discussed. We have used all concepts, that it is a special case, vector is given in Cartesian coordinate. If you see symmetry, that is a spherical symmetry. But since you are using A dot dl over the circle, you have to use cylindrical coordinate. So now using cylindrical coordinate, you have to calculate A dot dl. So how to write dl? You have z is equal to 0 plane. This is z is equal to 0 plane. This circle is z is equal to 0 plane. So dl will be dx x cap dy y cap. So what will be A dot dl? Y dx plus x dy. This is minus of y dx plus x dy, x square plus y square. Now you know that x is r cos phi and y is r sin phi. You have to write A dot dl in cylindrical coordinate. So dx can be written as minus r sin phi d phi, and dy is r cos phi d phi. So what will be A dot dl? So minus y is r sin phi and dx is minus r sin phi d phi, plus x is r cos phi and dy is r cos phi d phi, divided by x square plus y square is r square common, cos square phi plus sine square phi. So this will give you minus minus plus r square sine square phi plus cos square phi d phi by r square. So r square will cancel out. This will give you simply d phi. So a dot dl is d phi. So what will be closed a dot dl? Integral d phi, and phi will be 0 to 2 pi. So if you integrate this, this will be 2 pi. So this value is 2 pi, not 0. Del cross a dot dA will give you 2 pi. So let us take another example. This vector A is given. Vector A is x z square x cap minus y z square y cap plus z x square minus y square z cap. So first part, find the volume integral divergence of A d tau over the volume over the region x varies from minus A to A, y varies from minus B to B, and z varies from 0 to C. And B part, find, let us calculate surface integral A dot dA at z is equal to C surface. C is some constant. C is constant. This C at z is equal to C surface. And then C part, what will be A dot dA through rest of the boundary? Rest of the boundary. So let us calculate it. So first find divergence of A. What will be divergence of A? So first term will be z square, then minus z square, and then x square minus y square. This is ax, ay, az. So differentiate with respect to x, z square, y minus z square with respect to z. So this is simply x square minus y square. So what will be volume integral? So volume integral will give you x square minus y square. This is dx, dy, dz. X varies from minus a to plus a, minus b to b, and z will be 0 to c. So calculate this. Z will give you c. then x is minus a to a, and with respect to b you will get this is x square y minus y cube by 3. Limit of y is minus b to b, then dx. So this will be minus a to a. So what will be this value? So this is x square into 2b. So calculate this. Find out the integral. What will be this integral value? What will be integral value in this case? Calculate the final integral. Please verify this integral.
Sir, it's 2bx square minus 2b cube by 3.
Final answer is what will be final answer? I think you will get
4 by 3
ABC
by 3
ABC a square minus b square.
b square.
Please verify it.
Yes, sir.
This is the volume integral. 4 by 3 ABC a square minus b square. So that is the first part. Now in B part, what will be surface integral at z is equal to c? So dA is at z is equal to c, dA is given by dx dy z cap. So this integral will be a dot dA will give you c times again x square minus y square dx dy. Limit will be minus a to a and minus b to b. Again, if you integrate this, you will get same value, 4 by 3 ABC a square minus b square. Same integral. And then last part. In C part, you have to find A dot dA through rest of the boundary. So you can use divergence theorem. We know that divergence of A d tau is closed A dot dA. So that is A dot dA at z is equal to c plus A dot dA through rest of the boundary. And you can see these two are equal. These two are equal. Same value. So this will give you A dot dA through rest of the boundary. This will be 0.
0.